In this section, I want to talk about the idea of representing data by just a few numbers. Data usually comes in many numbers, and it's very unwieldy just to have all data points reported and no kind of encapsulation of them. Just like with graphs, it's a good idea to have your data encapsulated into something small so you can get a good feel for what it represents. So suppose I wanted to represent this data, so I have 10 heights of, let's say, university students here, and I want to represent that by one number that kind of is a good representative for these 10 data points. Now, just on your own intuition, have a look at these 5 possible representatives and determine which one you think would be the most appropriate. So just pause the video now and have a quick think. Okay, so I feel like the vast majority of you would choose 66 inches for height as the representative number. And the reason is, well, let's talk about the ones that in no way represent the data. So if you look at this, these data points go between 60 inches and at largest 73. Numbers like 80 and 52, they're way outside our data set. So this is something along the lines, if you're thinking of feet and inches, so there are 12 inches in a foot. So 66 inches is like 5'6". 80 inches is, well, 80 divided by 12. So that's something along the lines of 6'8", I think. And 52 inches is something along the lines of 4'4" or something. So these ones in no way represent the data points here, so we can automatically cross them out. 73 inches and 60 inches, while they do appear in the data set, they're kind of at the extremes. So we feel like they don't represent the data as well as something like 66 does. So we don't want to pick those either. So the reason that we gravitate towards picking 66 as something that would be a fairly good representative of this data is it's kind of in the middle. It's in the center. So close to the center, and I'll put that in quotes, of the data. And we have to really think about what we mean by center. So we're going to talk about 3 ways to think of the center of the data, and then learn how to calculate those. And those you've probably seen before, so 3 different centers. First one is, of course, the mean. The second is the median. And the third is the mode. And quickly, I'll tell you what I mean by each, and then we'll do some examples. So the mean we're thinking of as either the balance point of your data, or if you wanted to share all of your units over 10 data points, in this case equally, it's how many would be in each data point. So it's fair share, and I'll explain that with an example in a little bit. Median's kind of easy to think about. It is the middle of the data. So if you lined up your data in order, it's the middle of the ordered data. And mode is, of course, the most common. Data point. Data value, I guess. So let's explore these 3 different types of center. All right. So when we're talking about the mean is kind of the most common idea of an average or measure of center that you'll come across, and you've probably seen it before. So the whole idea, and there's two of them. So imagine that we had this like little play data set. So it's your data points are 2, 3, 4, 5, and 6. So the mean, we can think of it as the balance point of this data. And what does that mean? Well, that means that, well, if we had this, imagine an infinitely long and infinitely thin number line, and we had these little weights. And at each data point, we dropped a little weight. So the mean we can think of as the place where if you had a little wedge or something and you wanted to balance this number line on it, where would you have to put this wedge so it would balance? And the answer is, right in this case, at 4. So wherever this number line would balance is the mean of the data. And for example, maybe if we moved one of the data points, I'm going to erase this in a second and go back to normal, but maybe instead of 6, we had something like 9. Well, what happens to our diagram now? Well, if we extend our number line a little bit, so instead of having this little weight put on the number line at 6, what if it was put at 9 instead? Well, in this case, you could imagine that the balance point would change. There's something farther away now, farther to the right. So in order for you to balance this number line, you would have to move the balance point farther to the right. So in fact, it would be somewhere along the lines of here. So your balance point would change. It would move farther to the right. So that's one way of thinking of the mean. Another way is the idea of fair share. So imagine with this data set, so I'm going to go back to the normal data set. Instead of 9, I'm going to put 6. There we go. So I can visualize my data points like this. So 2, here's 2 dots. 3, here's 3 dots. 4, 4 dots. 5, 5 dots. 6, 6 dots. So there are my 5 data points. So how many dots do I have in total? Well, you just add them up. There's 20 dots. So imagine I wanted to share these 20 dots equally, fairly, among each of the 5 data points. I would just divide the number of total dots by the number of data points. 5, and we get that. There are 4 dots in each data point now. So the mean, or the balance point in this case, would be 4. So the mean is 4. And thinking of it in the fair share model gives us a way of calculating the mean. All we're doing is we're adding up the data points, the values of the data points, and we're dividing by the number of data points. So the mean, and sometimes you'll see the notation x with a little bar over it, and we call that x bar. So you might see that as well. It's called x bar. And so what it is we're going to take the sum of the data points and we're going to divide by the number of data points. So in our example that we have here, so I just up top, I have the data points from the previous slide. So the mean of our example up here of the heights So all I'm going to do is I'm going to add these together. So 62 inches plus 67 inches plus 71 inches. And in the interest of space, I'm just going to put some dots here. But what I'm doing is I am just adding up all 10 of these data points. And I'm going to divide by the number of data points. And I've counted, and there are 10 data points. And we get 661 over 10, which is, if you want it as a decimal, 66.1 inches. So that is the mean or average of our data set. The next measure of center I want to talk about is the median. And the median is kind of the easiest idea out of all of these in some sense. All it is the middle of the ordered data. And that word ordered is important. A lot of times we'll get a data set and it won't be ordered. It'll just be probably in the order you collected it, but not in the order from least to greatest. So that's how we want to order it, in numerical order. And so we're looking for the element in the middle. So I think it's kind of easy to see that, well, if a data set has an even number of elements, well, there's no element in the middle, so we'll want to take the average of the two that are in the middle. And especially if you have large data sets, there's a little hint to determine, once you have your data in order, which elements you need in order to calculate the median. So what you do is you just take the number of data points that you have, n, and add 1, and then divide by 2. And we'll use that hint in the example that we have below. So again, this is the same data that we've been working with, the height of the 10 students from the previous examples. So the first thing we're going to do is we're going to order our data set. So we're going to write it from smallest to largest, and that's what I did here. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So I'm going to calculate 10 plus 1 divided by 2. And that gives me 5.5. So obviously there's no 5.5 data point, but this represents, well, it's in between 5 and 6. So this represents the average of the 5th and 6th data point. So I'm going to find the 5th and 6th, 1, 2, 3, 4, 5, 6. There's the 5th and 6th right here. So I'm going to take the average of those, so that is 65 plus 67 divided by 2, and that gives me 66. So we say the median, and a lot of times we use the capital letter M for that, so the median, which we use the capital letter M, in this case is 66 inches. Maybe one more quick example with median, just to see one with an odd number of data points. So suppose we had the following data set. Let's find the median. I'm just going to write it in order. So let's say I got this data set and then I ordered it, and it came to the following: 2, 3, 5, 9, 17, 19, 23. So there is my data set. So I have 7 elements, 7 data points, 1, 2, 3, 4, 5, 6, 7. So the median is going to be the one in the middle. So in this case, it's kind of easy to see you can kind of go backwards. So here are the end ones, and then the next two, and then the next two. So this one is in the middle. But just to see how that little formula works, I'm going to take the number of data points, add 1 to it, divide it by 2, and I get 4. So I want the 4th data point is the median. So in this case, there's no calculation to do. It's just the 4th one. So M, which is our median, is of course 9. The final measure of center I want to talk about is the mode. And the mode is just the most common value of a data point that you have. So in the example that we're looking at, the 10 heights of the students, we had 3 students that were 62 inches tall. 62 appears more than any other data point. In fact, all of the other values for the data points appear exactly once. 62 is the one that appears more than once. It appears in this case 3 times. So the mode in this case, because it appears the most, is 62. Now, if you have a data set where there's a tie for the most common element, like below, if you look below, there are 3 1s in this data set, and 3 3s and 3 4s in this data set. Everything else has either 1 or 2 instances of it. Then the mode in this case is going to be 3 different values, 1, 3, and 4. We call this a trimodal data set. So there's not too much more to say about mode here. Just look for the most common value for your data points, and that is your mode. I guess I should say one more note. So we'll call this note 1. Note 2 will be the following. If no value is repeated, the data has no mode. So if you had something along the lines of a data set like this, 2, 4, 9, 17, 23, 31, well, all of those appear exactly once. So nothing is repeated. There's nothing that's most common. So there is no mode.